Very good evening to all of you. Okay, in today's discussion, we will start a new topic. So, before that, what are the things we covered in the previous classes, right? So, we studied the phenomenon of dispersion, right? So, splitting of the colors, the white color into its component colors, that is dispersion, that we already covered, right? Then we studied what you mean by refraction, right? When light passes from one medium to another medium, it changes its direction, right? It bends towards the normal or away from it. That is refraction. And we studied reflection, the phenomenon of reflection also, right? So when light hits on a smooth surface, it reflects back, right? So these three phenomena, reflection, refraction, and dispersion, we already studied, right? So today we will study, or we are going to discuss, or we are going to find out what is the cause or how a rainbow is forming. You know the rainbow, right? You would have been seen the rainbow in a rainy day, right? So you should understand, right, what is the cause of the formation of rainbow, right? You should understand it. So that we will discuss today. Okay. So how the dispersion, reflection, and refraction causes the rainbow. What is the importance of these three phenomena in rainbow formation? So that we will discuss today. After that, we will study a new topic, that is scattering. What do you mean by scattering? Okay. So after understanding the phenomenon of scattering, we will study the Tyndall effect. Then, after in-depth understanding of the phenomenon of scattering, we will find out the reason for certain natural phenomena, like why the clouds are white, why the sun in the day and early morning and evening is red in color. Okay, why in highest altitude it's like when we flying in high altitude, why the sky looks dark. So we will find out all the answers for all these questions. Okay. So before going to this topic in detail, we should understand one basic topic, that is frequency and wavelength. What do you mean by frequency and what do you mean by wavelength? Because we will discuss like all the explanation, or when we going to find out the reason for certain natural phenomena, all are related to some of the like these terms will come, frequency and wavelength. No, all the places. So you should understand the concept of frequency and wavelength before moving to the rainbow formation, before moving to the topic scattering. Okay, so first I will explain what is frequency and wavelength. Okay, see, frequency of a fan, like fan is rotating. Okay, one complete rotation. Can you imagine, Devananda? One complete rotation.
Yes, sir.
Okay, one complete rotation. Just compare that complete rotation with this. Okay, here I am taking a signal. This point to this point. I'm taking this point as A, this point as B. Okay. So here A to B is a complete cycle of the signal. Okay, which is equivalent to a complete rotation of the fan. Okay, just for the understanding purpose, I'm telling. Okay, for comparison, a complete rotation of a fan is equal to the complete cycle of the signal. Okay, from A to B. Okay. Next, B to, I'm taking another point, C. B to C is the second rotation of the fan. Okay, when the fan complete the second rotation, complete rotation, then the signal will reach from B to C. So how many complete cycle? Suppose fan rotates two times. During that time, the signal transfer, like how many complete signals we are getting? Two, right? Then the how many complete
Yes,
signal?
sir.
Two, right? Two, right? So the fan rotating or fan completing its two rotation in 1 second. Assume fan completes its two rotation in 1 second. Okay, then we can say the frequency of the fan, the frequency of the rotation of the fan is 2. Got it? Okay, but in the case of
Yes,
signal,
sir.
we have to count how many complete cycle passing through a point in 1 second. So here I am taking a point P. Okay, and through this point, how many complete signals? This is transferring. Okay, the signal will move, right? So suppose this two complete signal is passing through this point P in 1 second. Then the frequency of this signal is 2. We say it is 2 hertz for 2 cycles. Got it? If three complete cycle, you have to understand what is a complete cycle in the case of a signal. If 10 complete cycle passing through this point P in 1 second, then we can say the frequency is 10. Got it? Clear, Devadanta? My voice having some
Yes, sir.
problem or some delay. Is it okay?
No, sir, it's okay.
Now frequency is clear. Now you just see what is wavelength. Wavelength is the distance between the, what is this? Crust or trough? What is this?
Crust.
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 So two consecutive crust, what is the distance? That is, we'll call it as a wavelength, right? That we call it as a wavelength. So this is a wavelength. Okay. So it is clear like what is frequency and what is wavelength. The distance between two crust or two trough. This is also, this distance is also wavelength lambda. Okay. Now frequency and wavelength is clear to all of it. Now you just tell me, Abhi, you just tell me, okay, if I am increasing the frequency, very, very important concept. If I am increasing the frequency increases, okay, what will happen to the wavelength? Abhi, if I am increasing the frequency of this signal, what will happen to the wavelength?
Sir, it will
It will
increase.
decrease, right? Both are inversely proportional. If I am increasing the frequency means this cycle will come closer. Increasing the frequency means it will come like this. This is having low frequency. So this is F increased. Okay. This is F down, decrease. So here lambda will be, wavelength will decrease. Here lambda will increase. So very important concept. Frequency and wavelength are inversely proportional. Very, very important concept. Okay. When frequency of a signal increases, its wavelength decreases. Register in your mind. Okay. So you should understand what is frequency, what is wavelength, then frequency is inversely proportional to, sorry, wavelength. These concepts should be very clear to. Now we have studied this, right? With geo. When light passes through this prism, it splits into its components, right? Component colors, right? Okay. Violet, indigo, blue, green, yellow, orange. Okay. So here, this red light is having high wavelength. Lambda is high. Wavelength is high. Then frequency will be low. Okay. Frequency will be low. Violet light having wavelength lower, high frequency. That means the violet light, it is like or we can say this is arranged in an order such a way that the frequency is decreasing from bottom. The violet is having high frequency. Violet color having high frequency. For indigo, it's get reduced. Then again it's reduced and reduced. And the lowest frequency. Which color is having lowest frequency?
Red.
Red
Red.
color. Okay, register in your mind. Violet having high frequency. Violet color having high frequency in the visual spectrum, and red light is having lowest frequency. Okay. Now you understood what is frequency, what is wavelength, what is the relationship between frequency and wavelength, right? This already you understood. And you studied which color is having highest frequency. Violet color is having highest frequency and red color is having lowest frequency. Now let me ask one question. Which color is having which color is having highest wavelength? Think.
Red.
Hmm?
Violet.
Which
Red,
color
sir.
is having
Red.
highest wavelength?
Red. Sir, red.
Red.
Let me
Red.
note down.
Red.
Hmm? Red or violet? Which is having highest wavelength?
Red. Red. Yes, green, sir.
Hmm? Red I can. Any other color? Devaganga. Which color having
Sir,
highest?
red.
Red. Hazel is saying red. Devaganga is saying red. Who else saying red?
Sir, red. Sir, red.
Red.
Sir, red. Sir, red.
Red. Right? So all are saying it's red color. So red color is having highest wave. So this way you have to connect and remember. You have to understand what is frequency, what is wavelength, how frequency and wavelength is related. Okay. Then keep in mind violet light is having the highest frequency. Okay. Red is having the lowest frequency. In this order you have to remember. Otherwise you will get confused. Okay. Then based on the relationship between frequency and wavelength, you understand which either red or violet is having highest. Okay. So wavelength is nothing but its length of the wave, right? Approximately, if you like, we can say it's something related to the length of the wave, right? Okay. Since a red light is having highest wavelength, okay. Since red light is having highest wavelength, we can see the sun or the sky as a reddish in during daytime and during early morning and in the evening time, right? Early morning and evening time. What is the color of the sky? Early morning and it's reddish, right?
Orange.
Orange reddish color, right? It's because this red color is having highest wavelength. All other which is having the lowest wavelength will scatter and will lose. Because it's like sun will be in the horizon, right? It should come from a long. It should that sunlight need to travel for a long distance, right, to reach our eye during the evening time and during the uh, morning time, early morning time, right? So all other lights will scatter. Red also will undergo scatter, but less amount of scattering. So only red and orange will reach your eye, which is having high wavelength, right? It can travel long distance. So that's why we are seeing the sun, the sky, as a reddish during the early morning or the evening. Okay, okay, fine. Now just see this figure. What you can interpret from this? This all of you, please. This figure. This is different color and the signal is also represented. What difference? What you can interpret from this pattern? All of you. The same thing. Same thing what we discussed, which is having highest frequency, which light is having higher, which color is having highest frequency, which color is having lowest frequency, which color is having highest wavelength, which color is having lowest wavelength. All these things you can get it from this, just a pictorial representation. Okay. So which light, which color is having highest wavelength? All of you, please. Which color is having highest wavelength from this big figure?
Right. Right. Right.
Right? You can see, right? This distance itself, I here. Which color is having lowest wavelength?
Violet. Violet.
Violet. Devapriya,
Yes, sir.
which light, which color is having the highest frequency?
Violet.
Violet. Violet is having highest. Now it's clear to all, right? Right. Now, okay. Now today, now only we are coming to our today's topic. Okay. So we are going to find out the reason for some natural phenomena. Okay. Some natural phenomena which you would have been called like seeing in your day-to-day life, but you may not be knowing what is the actual reason for this, right? Okay. First thing, rainbow. How it is formed? Any idea? How a rainbow is?
Dispersion.
Yes. Next, why clear sky is blue in color? Clear sky, not in the noon. Noon it will be white color. 1 o'clock or 1 p.m. or 12 p.m. it will be white color almost. But most of the time, the clear sky is blue in color. In early morning and in the evening, it is reddish, right? But in between, when the sky is clear, there is no clouds, nothing. We can see what is the color of the sky? Blue.
Blue.
What is the color of the sky? Blue, right? What is the reason for that? Then clouds. Clouds. What is the color of these clouds?
White. White.
Right? Only white. When
So sometimes
cloud,
black.
yeah, sometimes you can see it's black color also, right? That is different case. Most of the time, if you see, like in a clear sky, okay, suppose there is no rain, there are clouds also floating, right? This color will be white only, right? Okay. So what is the reason for that? Okay. When the clouds are very closer to each other, rain is going to come, and if you see the clouds, it will be looks like dark, right? Dark ash color. So in that case, it is not penetrating the sunlight, it's completely blocking the sunlight. That's why we are seeing it's a black color. Okay. Okay. But in normal situation, suppose the density of the clouds are very less. Okay. Few clouds are there. Then the color of the clouds is actually it is white. Correct? So what is the reason for that? What is the reason for that? Why clouds are white in color? First one is what is the reason for or how rainbow is formed? And second, why clear sky is blue in color? Then third question, why clouds are white in color? And fourth one, color of the sun at sunrise and sunset is reddish. And fifth one, you would have been seen traffic light, right? Traffic signals, lot of traffic signals when you're moving through the road, right? What is the color of this traffic signals? Most of the signals, not only the stop signal, right, left. U-turn, all are in which color?
Red.
Red in color, right? Like this. These are different traffic signals, right? But I
Yes,
mean,
sir.
seen, yeah, when you travel through the road, you can see all these different signals, but all are in red in color. What is the reason for that? Okay, so we need to find out the reason for all these questions. Okay, if you found the answer for all these questions, this chapter is complete. Oh, okay. The first rainbow is due to what? Dispersion. That we already studied, right? What is dispersion? We already studied. So no.
Yes, sir. Yes, sir.
Yes. Dispersion we already studied. The other four, clear sky, why clear sky is blue, why clouds are white in color, why the color of the sun and sunrise and sunset is reddish, and why traffic light is red in color, all we can understand after studying what is scattering. What is scattering? Okay, so the 2, 3, 4, 5, this phenomena, all these questions we can answer after studying the phenomenon scattering. Okay, so what we are going to study next? What we are going to study next? Abhi, what will be? എന്തായിരിക്കും? What we are going to study next, Abhi? Hmm. What we are going to study next? You need to find out the answer for these questions, right? 2, 3, 4, 5. So what we need to understand? This is, I told this is due to scattering, right? So we need to understand what is scattering. Then only we can answer for this question. Yes or no? Yes or no? Yes or no? Aaron, Aaron Elsa.
Yes, sir.
What we are going to study now?
Scattering.
Scattering. Okay, let's see. What is scattering? Okay, so before going to scattering, okay, we just see how the rainbow is forming. When you can see a rainbow, sunny day
After rain.
Right.
after rain. Okay, where you can see the rainbow?
Sky. In the sky.
Sky, that's okay. Correct, sky only. But where? If sun is in the east, you can see the rainbow in the direction. Opposite direction of the sun. A rainbow is always formed in a direction opposite to that of sun. Did you observe this? Okay, കണ്ടിട്ടുണ്ടോ? ശ്രദ്ധിച്ചിട്ടുണ്ടോ? ശ്രദ്ധിച്ചില്ലെങ്കിൽ ഇനി റെയിൻബോ ഇപ്പൊ കാണാൻ പറ്റുന്ന സമയമാണ്, മഴയുണ്ട്, ഈവനിങ് ടൈമൊക്കെ മഴ വന്നതിന് ശേഷം നോക്കുക എവിടെയാണ് റെയിൻബോ ഫോം ചെയ്യുന്നത്, എവിടെയാണ്. Then if you see some rainbow, just think about where is the sun. Sun will be back side. If you see rainbow front side, the sun will be in your back side. Okay, so both will be in opposite direction. So okay, so how, what will be the cause of, you like, we already seen that it is due to dispersion, right? So after rain there will be lot of small water droplets available in the atmosphere, right, small water droplets, small, very small. These small water droplets will act as a prism, will act like a, or will behave like a prism, like this. This is a droplet. Okay, this is a droplet. Okay, I just enlarge the size. Okay. This is sunlight, so opposite to the sun. So if I am standing here, okay, so what will happen? The sunlight will pass through the droplet, right? dispersion will happen. Dispersion is what? What is dispersion? What is dispersion, Devananta? What is dispersion? What is dispersion, Devananta? Iron, what is dispersion? Iron, what is dispersion? Dispersion, dispersion. What is dispersion?
Sir, I don't know.
Hmm?
I don't know.
Saila. Dispersion than arilla.
Yeah.
Okay. Dispersion is splitting of light into its component colors, right? So that we studied in when we studied the prism, right? Last class. Okay, the splitting when light passes through a prism, it split into its component colors. That is dispersion, right? That is dispersion, right? So here this droplet act as a prism. Each droplet act as a prism. So when light passes through this droplet, dispersion happens. That means it splits into its component colors. Okay. So the first phenomenon is happening is refraction. Then it's due to the refraction again it splits into its component colors. Okay. Then it travels and it hits on the other side of the drops. But here refraction no will not happen because instead of refraction it will reflect back. Okay. Why? There is a separate reason for this. Okay. We will call it as critical angle. One term is there, not included in your syllabus, dense syllabus. When the light hits on a surface with a particular angle greater than or equal to that angle, it will reflect back to the same medium. Refraction will not happen. Okay, just understand that. If the light hits the surface or the boundary of two medium with a particular angle, it will reflect back. That angle we will call it as a critical angle. Okay, it will not reflect. Refraction will not happen. It will reflect back and it will cause a internal reflection.
Sir, can you repeat the name of that angle?
Critical angle.
Okay.
Critical angle. Okay. So that after that angle, it will reflect back to the same medium. Refraction will not happen. So that's why this surface, like this is also junction, right, between two surfaces, water and air. Since the angle of incident is greater than critical angle, it's reflecting back the same. But here it's coming through again refraction and dispersion. Again, it's like refraction is happening. Okay, it's coming out from the drop. That's why this is the cause of or this way rainbow is forming. Okay, the upper portion is red. Why the upper portion? Because red is least deviation, right? It's because of its low frequency, high wavelength, it will bend less red. So that's why the top of the rainbow is always red. Question can ask, right? The top of rainbow is red color. Why it is not violet? You should be able to answer it. Because rainbow is forming like so I will come to that question last. Okay, just finish this. So this is the like this is a different things happening to create or to like the formation of a rainbow. So what are the different things or different phenomena included in the formation of rainbow? Non things. നിങ്ങൾക്ക് അറിയുന്ന കാര്യങ്ങൾ എന്തൊക്കെയാണ് കണ്ടത്? Okay, what are the different things happening when light passes through this droplet?
Sir, light is reflecting back.
reflection is happening. Tell me in the order. First, what is happening?
Refraction.
Yeah. At this junction, first refraction.
Refraction.
Then splitting into its components. What is that?
Dispersion.
Dispersion. And this point,
Reflection.
internal reflection. Total internal reflection. Right? So three phenomena. This junction, first refraction, then here splitting into its component, that is dispersion, then this again hitting here, it's reflecting back, so reflection, refraction, dispersion, and internal reflection. These three phenomena together are causing for the rainbow formation. So like this, I have considered only single drop, right? There will be 10,000 lakhs of droplets like this, right? So by combining all these, we will get a big rainbow like this. Okay, clear? How the rainbow is forming? Anuvind?
Yes, sir.
Clear, Priya? Clear?
Yes, sir.
Okay. Lakshminanda, tell me, what are the different phenomena happening in the water droplets in the formation of a rainbow?
So, refraction, dispersion, and internal reflection.
Okay. Now you understood what how we are
So,
getting a yeah.
so here is it necessary to specify that it's internal reflection?
Yes, you can.
Okay, sir.
The formation of rainbow is clear to all of you. It's because of dispersion mainly. Not main reason is dispersion, but it have refraction, then dispersion as well as internal. Okay. Now we are going to study new phenomena, that is scattering. Right? Scattering of light. Scattering of light. Scattering of light. What is scattering of light? From the name itself. Scatter. What is scattering of light?
Move to different directions.
Yeah. So if light hits some particles, right? So it will move in different direction. Like light is traveling from straight line. So there is some minute particles hits that particle, it changes direction. That is okay. So before going to the definition, let's see some of the photos. So you would have been see this, right? This type of light, when light passes through a window or small what do you call ventilator, like ventilator, small holes, you can see this type of behavior. Yes or no? This one, second one
Yes,
also,
sir.
thick forest would have been seen like this, right? Another one. So this is a plain water. Okay, two beakers are there. One beaker is having plain water. Okay, and second beaker having water. I have mixed with what? Mixed with
Milk.
milk. So what happened? This is become a colloid, right? Here there is no particles inside. It's a plain water, but here it became a colloid because there are the particles that are mixed. Like its size is a little bit higher, so this color itself changed like milky water, right? We call it as a colloidal substance. There will be some particles floating over this, right? Can you see this? I am using a laser beam passing through this beaker and this beaker also. I cannot see the path of the light here, right? I can see only the path here. Can you see that? This is also due to scattering. Here there is no particle. Here there are lot of particles, colloids. Since it is a colloid, there will be lot of particles. Okay. So when the light passes through this, it's not hitting anything, right? Any particle. So it is passing through that, but scattering is not happening. That's why we are not able to see that light. Here, the scattering happens. That's why we are able to see this light, path of the light. Got the point? Got the point? See, path of the beam of light passing through the plain water, true solution is not visible. But here, when light passes through a colloidal substance, we are able to see, or colloidal solution, we are able to see the path of that light. This is the path of the light, right? All these happening, these three phenomena are happening due to scattering. Okay? So if you want to see the path of the light, if you want to see the path of the light, okay, scattering should happen. Okay, scattering should happen. Okay, in a different scenario, different medium, light, white light is a combination of visual, violet, indigo, blue, right? Depending on the wavelength, scattering is nothing but what? When it's hit a substance, right? Light rays hitting a substance, a particle, it changes its direction. That is scattering, right? Right? But the amount of scattering of violet light, indigo, blue, orange, yellow, red, all are different. All are different. Based on what? Based on the size of the particle. Based on the size of the particle in the colloidal substance, colloidal solution. How it is related? That we are going to see in the next slide. Okay. So just understand all these phenomena, this path of light here you are able to see. Here also the path of light you are able to see. Here also the path of light you are able to see. All because of scattering. All because of scattering. Just understand that. Now we are going to see the definition. What exactly scattering? It is scatter. When light hits a particle, it scatters. It changes in direction. Simple. Read the statement. The scattering of light is the phenomena by which a beam of light is redirected in different direction on interacting with particles present in the medium. See this figure. See this figure. What is this? Source of light. Let it be sun. This is source of light. Let it be sun. These blue are different particles which are available in the atmosphere. Oxygen, nitrogen, different gases are there, right? Minute particles, right? Different dust, right? So different minute elements are there, right? Very small elements, right? So when light passes through this, light is a combination of violet, indigo, blue, green, yellow, orange, red. Tells you, right? You see, just see this red light. I just included two lights here. One is blue, another is red. Okay, just for understanding. All lights, all colors are available. Okay, violet, indigo, blue, green, up to red. Okay, just for your understanding purpose, I just included two colors. One is blue light, another one is just separated. All together, it's coming as a white light. Just think violet light. Sorry, just think blue light and just think red light. You can see that red light is not undergone any kind of dispersion, okay, any kind of scattering, or you can say my very minimum amount of scattering, right? But you see the blue light, it's hitting all the particles, right? Yes or no?
Yes, sir.
Yes or no? What could be the reason? It is something related to its wavelength. I'm just drawing a signal just for your understanding of red light. Okay, high wavelength. Now let me draw the blue light. Are you getting something?
Yes,
Blue
sir.
light is having high frequency, that means low wavelength. Red light is having high wavelength, right? So red light is having high wavelength and blue light is having low wavelength. So high wavelength means the chances of hitting the particle is less, right? Understood? Its wavelength is high means if the wavelength is higher than the size of the particle, then the chances of hitting that particle is less. So since a red light is having highest wavelength, it will undergo less hitting or less scattering when it passes through the atmosphere. Okay. So from this figure, we can come to a conclusion that the scattering of different light components depends on the size of the particle as well as the wavelength of the light components or the component colors. If the wavelength is high, the chances of scattering will be less. Right? Wavelength is high means the chances of hitting is less, right? But the wavelength is low means the chances of hitting is high. So now,
Yes, sir.
yes, clear, Anu,
Yes, sir.
Matthew.
Yes, sir.
Okay. So if which now just think which light, which color component will go undergo higher scattering. Devagana, Devagana. Which color?
Sir, blue.
Hmm?
Violet, violet.
Violet, right? Violet color will undergo highest amount of scattering because that is having the lowest wavelength. That means highest frequency. The chance of hitting are more, right? Clear. Now you understood what is scattering. When light hits the particle, it changes its direction. That is scattering. Then how the scattering is related to the size of the particle and wavelength of the light color components. The wavelength is high means the scattering is less. Wavelength is low means the scattering is clear to all of you.
Yes, sir.
Devananda,
Yes, sir.
clear. Kopika,
Yes, sir.
okay, fine. Now, Tyndall effect. Tyndall effect, nothing but it's scattering only. When light passes through a colloidal particles, it scatter, light scatter, right? That is, we'll call it as a Tyndall effect. Okay, both are same only. The scattering only. The color of the scatter, but this colloidal substance you are right. Okay, that's when light passes through a colloidal particles. We'll call that phenomenon. That type of scattering we'll call it as a water mixed with milk is a colloidal solution, right? Right. So light, when the phenomenon of scattering of light by the colloidal particles is known as Tyndall effect. Very, very important. Tyndall effect. Okay. The scattering depends on the size of the particle, okay, and the wavelength that we already discussed. Now, suppose this point also depends on wavelength and size of the particle, right? If the size of the particle is very less, okay, only what do you think? If the size of the particles are very low, very small, okay, then it's having but Vibgeo, right? Only if the size, like so for example, uh, only those color components which is having a wavelength. Suppose this particle having a size which is equal to 200 nanometer. Okay, this is a particle having size 200 nanometer. Those light components which is having wavelength less than this will undergo scattering, right? ഇതിനെക്കാട്ടിയും സൈസ് വേവ് ലെങ്ത് കൂടിയതൊക്കെ ഇത് കവച്ചു പോകില്ലേ? അപ്പോ if the size of the particle is 200 nanometer or x nanometer, those color components which is having wavelength less than this 200 nanometer will undergo scattering. Okay, so if the size is bigger, okay, if the size of the atmospheric particle is bigger, then all light components, violet, indigo, blue, orange, red, all color components will undergo. അല്ലെ സൈസ് പാർട്ടിക്കിളിന്റെ സൈസ് വലുതായ എന്ത് പറ്റും? റെഡ് ലൈറ്റിനാണ് ഹയസ്റ്റ് വേവ് ലെങ്ത്. ദാറ്റ് വിൽ ഓൾസോ അണ്ടർഗോ സ്കാറ്ററിംഗ്, right? So if red light is undergoing scattering means all other color components definitely undergo scattering, right? So if the size is bigger, if the size of the particles is bigger, all the components will undergo scattering, and what will happen? The resultant will be white color. All light components will undergo scattering and it will spread across. So again, all the light components will combine together. So it's again we'll get a white color. So this is also your to understand. Okay. If the size of the scattering particle is large enough, then all the color components will undergo scattering, and since all undergoes, right, all the bits are undergoing scattering, so no particular color റെഡ് ലൈറ്റ് മാത്രമായിട്ട് നമ്മളടുത്ത് വരില്ല, വയലറ്റ് മാത്രമായിട്ട് വരില്ല, എല്ലാം കമ്പൈൻ ചെയ്തിട്ട് വരും ഇൻ അവർ ഐസ്, റൈറ്റ്? സോ അഗൈൻ വി വിൽ ഗെറ്റ് എ വൈറ്റ് കളർ. ദിസ് is also to clear. Okay, so what is scattering? What is the cause of scattering? How the scattering is related to the size of the particle? How the scattering is related to the wavelength of each color components? These things should be very clear to you, should be in your mind. Then only you can answer the questions based on this topic, scattering. Now, let us find out the answer for questions. Let us find out the answer for why clear sky is blue in color. Why clear sky is blue in color? Think something related to the particle size, something related to the wavelength. Blue light is having lowest wavelength, lowest wavelength. Scatter ചെയ്താൽ മാത്രമേ നമുക്ക് കാണാൻ പറ്റുള്ളൂ അല്ലെ, path of light, yes or no? That is first thing you have to understand. If there is no scattering, we cannot see any color. Black ആയിട്ടിരിക്കും. മനസ്സിലായോ? If atmosphere ഇല്ലെന്ന് വിചാരിച്ചോ, if there is no atmosphere, we cannot see the sunlight. ഫ്ലൈറ്റിൽ പോയിട്ടുണ്ടോ ആരെങ്കിലും? ഫ്ലൈറ്റിൽ ട്രാവൽ ചെയ്തിട്ടുണ്ടോ?
Yes, sir.
ഹൈ ഓൾട്ടിറ്റ്യൂഡിൽ ഫ്ലൈ ചെയ്യുമ്പോൾ we can see its black color, right? Completely. Yes or no? ശ്രദ്ധിച്ചിട്ടുണ്ടോ? No.
Yes, sir.
Yeah. When we fly like over the atmosphere, like very high altitude, you can like all the like the sunlight you cannot see, completely black, high altitude. So why? Because there is no atmosphere. That means what? The intense. There is no refraction. There is no nothing is happening, right? This scattering is not at all happening. So we're not able to see the path of the light. So it's completely dark. When flight traveling or flying over the high altitude, that is the reason. There is no scattering means we cannot see the path of the light. Basic concept register in your mind. If there is no scattering, you cannot see the light. You cannot see the color of the light. You cannot see the light. It's okay. So light having its components. If blue color component is undergoing more amount or high amount of scattering, then we can see the sky is a blue. If a red color is going higher scattering, then the sky will be red. If violet color is undergoing high amount of scattering, then the sky should be violet in color. Clear? Right? Now you just think which color will undergo in the sky. We have sunlight, right? White color, it's having mibjor, violet, indigo, blue, green, yellow, orange, red. Which color should undergo more scattering?
Blue.
Is it blue?
Violet, sir.
Violet, right? Violet. Violet, indigo, and blue, right? But see, we should able to like see the sky, clear sky as violet, right? Violet color is undergoing more amount of scattering, yes or no? Because violet is having what? Lowest wavelength, yes or no, Gopika?
Yes, sir.
Violet is having the least wavelength, so it should undergo the highest scattering. The sky should be, due to that, the sky should be violet in color, but we are seeing it's a blue. Why? Because there is a nerve in your head, in your brain, which detects the color. We call it is, I think it's crown or something. Okay, I forgot the name. Okay, there is a sense which detects the color of the light. Okay, the human brain eye detects blue color easily when compared to violet and indigo. Okay, instead violet and indigo, the sensitivity of human brain for the blue color is high. That's why instead of violet and indigo, we are seeing blue in color. Got it? Then how we can answer this question? Why clear sky is blue in color? How you will answer this question?
Because our brain processes it as blue.
Hmm?
Our brain processes
2 points
it
you have to
as
write. 2 points you have to write for this question. Why clear sky is blue in color?
Sir,
Yes,
the blue has shorter wavelength than red.
that's correct. But wavelength point you have to bring, but red is not required. For seeing anything, for seeing the light, path of the light, there should be scattering, right?
Sir, it will scatter the most blue light, the most.
No, violet, right? Violet is having the least wavelength, right?
Yes, sir.
Yeah. See, the point, just I'm telling, just uh, register in your mind. First point, for seeing the path of light, for seeing the path of light, scattering should happen. Okay. For seeing the path of light, scattering should happen. So that is happening in atmosphere, that we know. But since violet and indigo having the least wavelength, it is undergoing high amount of scattering. Okay, if you sort the amount of scattering, violet will be higher, then indigo, then only blue. Okay, but actually the sky should be, the clear sky should be violet color. Okay, actually the sky should be violet color, but since our brain or eyes are more sensitive to blue color, we are seeing it as a blue. These points you have to write. Okay, I will share these notes. Will be there anyway. 2 points. The wavelength point should come anyway. How the wavelength is related. Okay. And the next point you have to write why it is not violet and indigo. Why it is exactly blue. That point also, it's because of the sensitivity of our eye. These 2 points should be there. Then only you'll get the complete. Okay. Next question. Why
So,
cloud? Yeah.
so then do all the organisms see sky as blue?
Depends. Because different organs, that depends on the the sensitivity of each different creatures. That will
Okay,
be,
sir.
that depends, completely depends on the sensitivity of eye.
Okay, sir.
If those creatures is having high sensitivities on violet, they can see it's a violet, because violet is actually undergoing more amount of scattering. You would have been seen violet in color. Next, third question. Why clouds are white in color? White color കാണണമെങ്കിൽ എന്തായിരിക്കണം?
Sir, the space of complex is very large, so
Yeah.
and scattered all wavelength of light almost equally.
Yes. The size of the cloud particles is very high. Okay. Now the point പറഞ്ഞായിരുന്നല്ലേ മുന്നേ. If the size of the atmosphere particles is high, all the color components will undergo scattering. Right? All the components will undergo scattering means what happened? All red, violet, indigo, everything. And all the lights together comes to our mind, comes to our eyes. So again it will combine, so we'll get it a white light. That's why clouds are white in color. Got it, Anvin? Got it, Anu?
Yes, sir.
Avani?
Okay, sir.
Lakshminanda?
Okay, sir.
Okay. So why cloud? Okay, പറയണോ? Why clouds are white in color, Lakshminanda?
Sir, because the size of the particles are bigger.
Yeah, size of the particles are bigger. Due to that,
Sir, due to that, the light will scatter.
all the light components, all the light components undergo scattering. അല്ലേ? സാധാരണ ബ്ലൂ ആവാൻ കാരണം എന്താ മുന്നേ ക്ലിയർ നോർമലി മൈന്യൂട്ട് പാർട്ടിക്കൽസ് ആണ്. ആ മൈന്യൂട്ട് പാർട്ടിക്കൽസിൽ വയലറ്റ് ഇൻഡിഗോ ബ്ലൂ ആണ് കൂടുതൽ സ്കാറ്ററിങ് ആവുക. അപ്പൊ നമ്മൾ വയലറ്റ് ഇൻഡിഗോ ബ്ലൂ ആയിട്ടാണ് കാണാം. സിൻസ് അവർ സെൻസിറ്റിവിറ്റി ഹയർ ആയതുകൊണ്ട് നമ്മൾ ബ്ലൂ ആയിട്ട് കാണാം ക്ലിയർ സ്കൈ. പക്ഷെ ക്ലൗഡ്സിന്റെ കേസിൽ sizes of the particle, cloud particles higher, all the light components undergo scattering. So all the light undergoes scattering, and then all the light after scattering will reach our eye. So all the light will absorb. Again, it will combine. So you will get white in color. Next, this you, I think already we discussed color of the sun. at sunrise and sunset is reddish. We will discuss this fourth question in depth in the next class. Okay, this is something related to wavelength, right? So I already explained in a single sentence. Since red light is having highest wavelength, since that's why it's travel long distance. So we have a separate topic for explanation for this. So we will discuss that separately. Now, this is also why traffic light signal is red in color. Same way because നമുക്ക് ട്രാഫിക് സിഗ്നൽസ് ലോങ് ഡിസ്റ്റൻസ് കാണണം അല്ലേ? We need to see, right? So red light is having what highest wavelength, so it can travel long distance. That's why we are using traffic signal in red in color. Got it? If we are using violet color, what happens? We can see very small distance, right? If I am driving a car, I need to see the signal, traffic signal as like long. I should be able to see that, right? But accidents or I can avoid the accidents, right? So that's why since red light is having highest wavelength, it can travel long distance. So that's why we are using traffic signal in red in color. Same answer for the fourth question also. Why color of the sun and sunrise are reddish? Because red color is having highest wavelength, so it will undergo less amount of scattering and it will reach our eyes. All other components undergo scattering and it will move away. It will not reach our eyes. That's why color of the sun is reddish in the sunrise and sunset. Okay, got the answer? So you have to study this, understand what is dispersion, then what is the cause of rainbow, what are the different things involved, refraction, dispersion, and internal reflection. Then next we discuss scattering. What is scattering? How the scattering is related to the size of the particle. How the scattering is related to the wavelength of the light components. If you understood that, you will be able to answer these 2, 3, 4, 5 questions. Okay. If you understood all
Okay,
these
sir.
things, this chapter is over. This chapter is over. Okay. So next class we will finish this chapter. We have to explain some more important points. 2 or 3 topics are there. So I think I can finish in the next class. Okay. So we will stop today.